is a neural network? Um, Similar to Cassidy's speech, there's two words here that we need to explain. A neuron is simply a variable, it holds a number. And a network just refers to how many neurons are connected together and they influence each other. A neuron only has one value and it has one dimension, and the size of the thing that it holds is called its activation. It can be between 0 and 1, and this mechanism is inspired by the brain. The neurons in our brain can either be on or they can be off. One possible way you might connect neurons is just to sum them up. Say neuron Y is just the sum of all the neurons that came before it or something. But there's a better, more intelligent way in which we can connect these neurons. This is the way in which a neural network is typically organized. This is quite a simple one. Each layer of neurons that you see here represents something significant. The first layer represents just the input. It's just the value of every pixel that we feed into our network. The output layer is just the result. And so in this case, it would just be two results. It'd be either there is a needle or there is no needle in the image. But we need to discern what these middle layers have to be. What could we hope that these middle layers possibly do? Well, let's think about how humans would go about saying there is a needle or there is no needle in this image. That's quite hard to talk about the whole image like that, so let's focus into a single part of the image. How can we tell whether or not there's a dark band running through, say, this circle in the image? How could we discern whether or not there's a dark band running through here? This is a much more simplified example. Well, to do this, we might say, okay, let's split the image into a grid of pixels, which it already comes in pixels. And then we might say, let's assign where the dark band that we're looking for would be. Let's assign that area to have positive multipliers. Let's say all those pixels are multiplied by something positive. And let's say all the pixels that aren't where we want our dark band to be, let's say they're all negative pixels. And let's say the areas that we're unsure about, let's say they're small values. Now this would mean that if the dark band is where we're looking for it to be, then we get a high value. If it's dark all around, then we get a low value because the positive and negatives would cancel out. If it's dark where we don't want it to be dark and bright where we want it to be bright, we get a negative value. So only if we do have a band where we want it to be would we output a positive value from this type of calculation. So that the rest of the image doesn't influence it, we can just color it purple as well, say near 0 weight. And so this is our new, more intelligent way of connecting neurons. We can say neuron Y is just the sum of some neurons that came before it, each multiplied by a certain multiplier. More recognizable, the higher the activation of neuron Y. These are called weights. That's the terminology used for convolutional neural networks. And the set of weights is unique for every neuron, so they can recognize different features. They each have a unique part to play in the network. So it could be that for this layer, as we talked about, they just recognize a band of darkness in some specific area. And then it could be that the next layer uses that layer to say, here's a sequence of bands that could be a continuous line section. It could be that the output layer simply takes where there are continuous line sections and just says, these line sections kind of look like a needle. And maybe that's how the neural network decides whether or not there's a needle in our image. Well, I say maybe because we don't have the energy to decide all these weights ourselves. There's thousands to discern, so we use computers to train our computers instead, and Nathan will talk about how we go about doing such a thing.
Yeah, so we wanted to